Good morning, everyone. In the last session, we discussed about the important concept called the linked list methods here. Now, here, if you observe, we have identified the different kind of method which are available under this particular linked list here. Okay. So now, if you see this, like lastly, we discussed about add all, clear method, remove all, remove if, retain all, and we discuss about the iterator methods here. Okay, so today we'll continue the what are the remaining methods we are having. Now, if you see, we discuss about the up to clear. So equal and hash code is going to be same similar to the array list whatever we discuss here. So to understand this equals method, how we implemented here, now create a like use this particular linked list and call this particular equals method. Now, if you see this, now it is coming back to the abstract list here. It is coming back to the abstract list. Now, abstract list, what we are doing here, we are calling this particular list iterator here. Okay, here we are calling the list iterator. Now, using the list iterator, we are calling this particular has next as well as so the E2 has next here. So here we are having two iterators. So the first one is E1 list iterator. Second one is E2 list iterator. So based on this, if the both objects are not equals to null, we are comparing with these two objects here. Okay. Now here we are calling this particular O1 dot equals method. So this is the way the equal sign to hash code method is implemented internally. Okay. Now going back to here. What are the important methods here? Split iterator. So split iterator is also one of the important concept. It's similar to the iterator and list iterator. The split iterator is provided from the version call 1.8 onwards. Now, if you observe what exactly this split iterator is doing here. What exactly the split iterator is doing here. Now, whenever I'm calling this, so what I'm getting here, split iterator, one object I'm getting here. So split iterator is one of the interface here. Now, if you go to this, so try advanced, we are having method and for each remaining. So if I want to get the one by one, now you can call this particular for each remaining, and internally it is calling this particular do while here. So which method basically it is calling? This is the one of the abstract method it is going to be called here. Okay, so these are the two methods. Now one more try split is a abstract method we are having, and estimated size we are having. Now this is the default method we are having. Now where we can see this, how it is implemented. Now to understand this, I'm going to put a breakpoint here. Now let me debug this application here. Now how this split iterator is implemented internally, we need to understand here. So to understand this, now what exactly we are going to do here, let me run this example in the debug mode. Okay, now we reach to the split iterator here. Now whenever we reached here, I'm calling this particular method called split iterator. Now observe carefully, what is an object we are getting. Now this is the new LL split iterator. Now what exactly the LL is providing? Linked list split iterator. Okay, so where we are having this particular LL, here we are passing the list object here. Now estimated we are providing -1 and expected mod count is 0. So which constructor we are calling it? Now if you see, so this is the constructor we are calling. This is the constructor we are calling. Okay, now whenever we are calling this, now what are the additional method we are having? Get to est. Okay, so this is the final method, but this method we cannot access outside of this particular linked list class because it is does not contain the public. So it is a default access modifier. We cannot access this particular method outside of this particular linked list class. Okay, now come back to here. We are having estimated method. So estimated size. Now what exactly it is doing here? So it is calling this particular get to est method internally. It is trying to return this particular estimated. Now we'll see how this particular estimated size is going to return. Okay, now I got it this particular split iterator. Now what I'm doing is I'm trying to call this particular split iterator dot. Okay, now if you see this, now this is the Now if you observe estimated size we are having, now whenever I'm calling this particular estimated size here, so now copy this, now go to this particular list iterator, now call this particular estimated size here. So what exactly this particular estimated size is going to be written here. So to understand this, now we need to call this particular method here. Okay, now come out of this clear. So we cannot call this clear method. It is trying to remove all the objects from this particular linked list here. Now try to execute this. Now we observe the split iterator internally. It is trying to creating the linked list split iterator object here. Now second one is estimated size. Now what exactly the estimated size is doing? Now if you see this, now we are calling this particular estimated size, and internally it is calling this particular get est. Okay, so now we reach to the get est method. Now if you see what is the linked list object we are having, now basically it is declared here. So it is not initialized as of now. We'll see how it is going to be initialized here. Now what is S here? Okay, so S basically it is does not initialize as of now, but we are having EST. Okay, we are having this particular EST. So when we provided this EST value as a -1, whenever we are calling this particular constructor. Now if you see this, I'm calling the constructor here by providing this particular EST as a -1. Now list we provided the current object. So this keyword is nothing but current object. Now expected mod count we provided as a 0. Now we'll see. Now here I'm trying to providing the EST value is going to initialize into this particular S variable. After this, what happening internally? I'm checking if it is less than 0. Okay, so whatever we provided, if it is a less than 0, now it is satisfied. So once it is satisfied, one more condition we are checking. Now what is another condition? Current list here. Okay, so now current list we are having. Now where we got this particular list here? Now if you see this, here we are providing this particular list. Now this is the parameter or constructor parameter. From where we provided, here we provided current object. Now if you see this, so these are the records we are having. Okay, so these are the records we are having. Now list these many 10 records we are having. 0 to 9 is nothing but 10 records we are having here. Okay, now the same thing here we are passing. Now this particular list we are initializing into this particular LST. After this, if it is a null, then we are going to get as this particular 0. But currently it is not 0. Okay, because we are having some values here. Now we'll see now what exactly it is going to return. Now this is the entire condition we are having. Now internally else block we are executing. So LST dot mod count. LST dot mod count. Now what exactly the LST dot mod count will do? It is trying to return whenever we are calling the constructor or method, the mod count is going to be increased here. Now if you see this, the LST dot mod count we are having 6. Now we are initializing into this particular expected mod count here. Now expected mod count is 6. So after this LST dot first. What is the first object here? Something like 10 here. Now if you see, this is a 10 object. Now what about this particular size? So what is the size we are having? 10 here. Now if you see this LST dot size 10. Now finally what you are understanding? The S it is going to return as a 10. Now estimated size. So what you are getting the estimated size basically, if it is a list is 0, you will get as a 0. Like if the list is null, you will get as a 0. Otherwise, under the list, how many values we are having, so those values we are going to get here. Okay, so those values we are going to get here. Now this is what we need to understand regarding this particular split iterator here. So finally, now what you observe here, whenever I'm trying to print this particular, so with help of this particular println, if I'm going to call this particular estimate size. Now what is the value I'm going to get here? Something like 10 I'm going to get. Okay, so now I'm going to get as a 10 here. Now here you can see, so this is the 10 value I'm getting, and this is the object we are printing. Now this is something like line number 34, whatever we created, it is trying to print this particular values here. Okay, so one method we observe under this particular split iterator. Now what are the additional methods we are having? Now if you see this try split. Okay, so what exactly this particular try split is doing here? Okay, now what you need to understand here, now if you see this, here we are calling the split iterators dot split iterator. Now using this particular order, so based on this particular order, now it is trying to divide this particular all the records here. Okay, now if you see, so first we'll print this particular split iterator. Now what is an object it is going to print here? Now if you see this, it is trying to print on the object references here. Okay, now how exactly this particular split iterator is going to work? So now what you need to understand regarding this particular split iterator here, now we observe it is trying to print this particular object references. Now we observe the one method called estimated size. Now I'm trying to call the one more method called try advance. Now if you see this, the try advance, what exactly it is taking here? Okay, so what exactly this try advance? Now if you see this consumer, so consumer is one of the functional interface. Consumer is one of the functional interface. Now if you go to here, now here we are calling this particular consumer as a parameter. Now, so if you see this, it is one of the functional interface. He is expecting one method call. He is expecting one method called accept, and it is having one parameter called type here. Now this is the default method. Now we need to discuss about this particular accept here. So how exactly these methods are going to be implemented internally? Okay, these methods are going to be implemented internally. Now, what you need to understand here, now if you go to here, here we need to provide the functional interface type. Now, whenever we are having functional interface type, either what we can do, we can call the lambda, or we can call the something like method references. Now, if you see this, now what I want to provide here, I want to call the method references. So how I am going to call the method references here? Now here, so where is the linked list here? Now linked list dot, now what we will do, now here, what are the methods we can call here? So I'm going to call as a add here. Okay, so it is a non-static. Maybe try advance is a static method. Now let's see. Here if you see, try advance is not a static method. Okay, so here we are trying to pass this particular linked list as a static non-static method. Okay, now here let's see any non-static method. So to understand the non-static method, what we will do, here I'm going to call the linked list and add method. Okay, now we'll observe how we can provide this particular add method. Let me run this. So this is a try advance here. Now what you are getting here, concurrent modification exception. So why we are getting here? Now basically here under this particular linked list 1255, here expected mod count and current mod count is not same here. Because of this, now we are getting this particular exception here. Because here, now what I am doing here I'm calling this particular accept method here, but internally what exactly I'm doing here? Internally, what exactly I'm trying to do here? Here, now if you observe carefully, I'm calling this particular get est. under this particular get EST, what you need to understand here, after calling this, I'm trying to find out this particular current and we are loading the current value. Now we are calling this accept here. Now here, so list.mod count and expected mod count both are not same. Because of this, now we are getting this particular exception. But if you see, using this particular try advance, what we can do, we can provide the value here. But here, now I'm using this particular lambda here. Okay, now here linked list dot add method. Now here I'm going to provide the value here. Here I'm going to provide the value here. Now I'm calling this try advance with help of this particular lambda now. Now if you see, so same we are getting here because here now linked list count is different and split iterator count is different here. So what you need to understand here. So basically in the try advance, now simply you can call here, system.out.println. Okay, system.out.println. Now if I'm going to print this, so what exactly you are getting here? Now you are getting this particular values here. So what are the values I'm getting here? Okay, now this is the 10 value I'm getting here. So why I'm getting this particular 10 value? First record, it is trying to print this. Getting the point? Only first record, it is trying to print this. Now if you go to this particular consumer, what is expecting here? Type, and the method type is void here. So this particular method, it is not going to be written any return type here. So this is, it is expected by this particular try advance here. Now consumer, so it is expecting this particular action here. Okay, now another important section, what you need to do here, if you see this particular try advance, it is trying to return as a boolean here. It is trying to return as a boolean. Now what exactly we can do? Whenever we want to check this, whether it is trying to returning true or false, so then we can go for this particular, advances. Now if you see this, now I'm doing the while. Okay, here I'm doing this particular while operation here. Now if you see this, now here if you observe carefully, so 10 to 100, 140. So 10 to 140. Now what you observe here, using this particular try advance, now what I'm doing here, I'm trying to print one by one record here. Okay, so and lastly, this is the println statement, it is going to be printed here. Okay, it is going to be printed. So this is main important we need to understand here. Now another important section here, instead of printing this particular println, now we can check the contains here. So what exactly we can check here? Now this is the value and linked list dot contains dot value. Okay, so now if it is returning true, now if it is trying to returning true, now what we will do? So we'll try to print this particular value. Now so if you see this, it is trying to return as a true value. So why it is trying to return as a true? Because here first it will try to find out the current record. So based on the current record is available or not under this particular linked list. Now it is available. Okay, so this is the different ways we can check with this particular try advance method, because here it is expecting the functional interface type. We can perform the various operations. Either we can go for the lambda or we can go for the method references. Now earlier we discussed about the println statement. Now we are discussing about the contains here. So this is all about the important section about the try advanced method. Now what is another method we are having? Try split here. Okay, try split. So what exactly the try split will do here? Now here we find out this particular split iterator. Now using this particular split iterator, now here try split. Okay, so this is a split integer split iterator we are having. Now, so what exactly it will do here? Okay, so what exactly it will do this particular integer split iterator, something like a try split here. Now, what you need to understand here, we'll observe basically it is trying to split this particular value. Now, I want to print this particular, okay, here integer split dot estimated size. Okay, estimated size we can print here so that we can observe how exactly the try split and another important section it is going to be work here. So now if you see this here, we are printing this. This is the true value we are printing. After this, now I'm calling this particular try split. And after this, now what we need to understand here, estimated size here. Now the estimated size is 9 is printing. But if you see here if you print this particular estimated size, now it is trying to print as a 10 here. Now why I am getting this particular 9? Because after the first record completion, it is trying to split into the second split iterator here. Now using the same, now we can call the remaining operators, whatever we want to provide here. Something like this particular try advance we can call, and same thing we can call try split here. Okay, so these are the important method we are having under this particular split iterator. So split iterator is basically it is going to work same like a iterator or list iterator. If you want to find out the has next value, how we will do, now you can go for this particular for each remaining. Okay, so for each remaining. Now what you can do, you can print this particular whatever the value we want to print here. So for each remaining is also internally it is expecting the functional interface type here. It is expecting the functional interface type. Now if you see, this is the default method, but internally is expecting this particular action. Now we are calling the try advance. Now we are calling the same try advance. Now here we are calling the same try advance. Now here you can see, so it is also similar to same, but this is the default method. If you want to call, you can. Otherwise, directly you can call this particular try advance. You can print whatever you want to perform with a functional interface style here. Okay, so these are about the important section we need to understand regarding this particular split iterator here. Okay, now once we complete this particular split iterator, now what is another important method we are having? So streams. Now these streams we will try to discuss in our upcoming classes later once we complete this particular collection frameworks here. Okay, these are the important method we discussed under this particular linked list, how each and every method is implemented here. Now going back to here, now what we need to understand is, so here also you will have a copy of method. Okay, copy of method. The copy of method basically like off method and copy of method, what exactly it will do? These are the default method which is available under the list interface. Now if you see this, so copy of method, it is not there because it is a default method. It is available under this particular list interface. Now if you go to this, now if you see this copy of method, here it will available. Okay, so here you can see this is the one of the copy of method. Now internally what is doing it? So list dot copy method is calling it, and it is a static method. Whenever it is a static method, with help of this particular interface name, directly we can access here. Okay, so this is we already discussed in the array list. So same concept, because list is going to be used for the linked list as well as array list here. Now, so these are the two important implementation classes we discussed for this particular list interface here. Okay, so to understand this particular hierarchy, so for whatever we discuss here, now this is a collection interface, and collection internally it is implemented by, sorry, is extended by this particular list interface and set interface, queue interface. So this list is implemented by the one is array list. Okay, second one is linked list here. LL is nothing but linked list here. So this is we discussed so far here. Now we need to move on to this particular set interface. But if we observe this particular linked list along with this particular list, now along with this particular list, now it is implemented from this particular queue also. It is implemented from this particular queue also. Now if you want to understand here what exactly the queue interface will do here. Okay, so we need to understand what exactly the queue interface is implemented by this particular linked list here. Now what are the queue related method we are having? Now we need to understand here. Now if you observe, this is the linked list. Now linked list is the implementation of this particular list interface as well as DQ. Okay, DQ. So DQ internally is extending from the queue interface. Getting the point? Now, so we need to understand so these are the methods. Okay, these are the methods. Now if you see this, so queue we are having these many methods, and DQ we are having these many methods. Now we need to discuss about these many methods, how these many methods are now implemented internally under the linked list, because linked list now along with the list interface is implementing from this particular DQ. So this is what we need to understand here. Now we'll focus on the queue and DQ related methods here. So to focus on this, first we'll go to this particular Boolean add method. So it is the same. Now we'll focus on the offer method. Okay, add method is similar to the collection related add method. Now we'll go to the offer method, how it is implemented. So to understand this, now what I will do, I'm going to comment out this. All the split iterator, here I will try to call linked list dot offer method. So offer method, now what I'm doing here, 61 I'm trying to providing. This offer method is coming from where? Queue interface. Now to understand this, now what we need to do, we need to put a breakpoint and we need to run in the debug mode. Now if you observe, we reach to this particular offer here, and internally, so this is the offer method. Now, so what we are doing? Offer method internally, it is calling the same add method. Same add method. So now if you go to the add method, now what exactly it is doing? It is trying to add link last here. Now link last, what exactly it will do? First it will try to find out the last node. What is the last node? The 40 related node is a last here. So it is going to load the 40 node. Now it is going to create a new node with the previous node as a last node and current value, and the next node is null. Okay, so it is a simple. Now newly created node we are making as a last node. Now if the L is null we are making first, but so it is not going to satisfy. For the previous node, the next we are making as a newly created node. So this is what we need to understand, how this offer method is implemented. It is a simple. In the linked list, offer method is internally, it is calling the add method. Okay, so one method we observe. What about this particular remove method? Now earlier we already discussed this remove method. Now if you go to here, now if you see this, so this is the remove method. Line number 20, whatever the remove method we are having. Now what exactly this remove method is doing? It is trying to remove the first node. Okay, it is trying to remove the first node here. So to understand this, now here, so simply I am going to call this remove method. Now if you see remove first. Remove first, what exactly it is doing this? Internally it is trying to load the first node. Okay, internally it is trying to load the first node. Now if the first node is null, we'll get an exception. Okay, we'll get an exception. But if the first node is not null, we are calling this particular unlink first here. Now whenever we are having, now I'm loading the item, I'm loading the next value. Now we are making the f dot item and next as a null. And if you see this here, we are making this particular null. If the next is null, last node is also null. But here next dot previous is we are making as a null. So that the current like first node, it is going to be remove the references here. So it is going to be eligible for the garbage collection. So this is what we need to understand regarding this particular remove first here. Okay, so now this method also we observe. Now we need to discuss about this particular pool here. Now what exactly this particular pool is implemented? Remove method internally it is calling the remove first, so that it will try to remove. Now if you go to here, so this is the remove first. Now we are discussing about the remove, and internally it is calling the remove first. So two method we observe how it is implemented. Okay, so now we need to discuss about this particular pool. Now if you go to this particular pool here, linked list dot pool method. Now this pool method internally what exactly it is doing is, so carefully observe, again it is trying to load this particular f, like again it is trying to load the first node we are loading here, and if the first node is null, we are returning the null. Okay, we are returning the null. If the first node is not null, we are trying to unlink first here. We are trying to unlink. Now what you observe carefully, the remove and pool. So remove, if the current object is null, it is throwing an exception, but pool, it is not going to throw an exception. This is the difference. Now if you see here, simply we are checking if the f is null, we'll try to return as a null. Otherwise we are trying to unlink this particular first node. Unlink is nothing but we are removing the first node here. Okay, so this is what we need to understand here. Now what about the remove one? Now if you go to this particular remove, so same thing, if you call this remove first here, if the f is null, we are throwing a no such element. Otherwise we are trying to call the method called unlink first. Okay, in the pool also it is going to call the same unlink, but this type of exception we are not going to throw. Okay, so this is only the differences between remove and pool method here. Okay, so we discuss about the pool. Now we need to understand the element here. What exactly this element will do here. Now to understand this particular element here, now what we can do, linked list dot element here. Now I'm calling this element. Now if you observe carefully, element internally it is calling the method called get first here. Okay, so get first, what exactly it is doing is, get first again it is trying to load here. Okay, the first value it is trying to load here. It is trying to load the first value. If the node is null, throwing an exception. If the node is null, throwing an exception. Otherwise it will try to return the first node item value. So this is the element. Element internally it is calling the get first. Now if you go to here, element we are calling from this particular queue. Now get first we are calling from this particular DQ. So what is the differences we can identify? So remove first and remove last. Now we'll throw an exception, and the same way pool first and pool last, those are not going to throw an exception. Simply it will return null. All the pool and peak related methods, simply it will return null. These methods are not going to throw any exception, but the get related remove method, the first and the last, whatever we are having, those are going to be throw an exception. Okay, so now we observe the element. Element internally calling the get first. Get first, basically what exactly it is trying to do, it is trying to load the first node. If the first node is null, we'll get an exception. If the first node is not null, we'll try to return the item value. This is the differences here. Now we need to go to this particular peek method. Now if you see this peek method, it will call the peek first here. Now see, I'm calling linked list dot. Okay, so peek method. Now what exactly it is doing? Now you can see, so first it is trying to load. If the first node is null, we are returning null. Otherwise, it is trying to load this particular item. So what exactly the element is doing? This is the element we are having. We are calling the get first. So it's checking whether the first node is null. If the first node is null, it will throw an exception. Otherwise, simply it will try to return the value. This is what we need to understand regarding this particular get first and element and peek method. So far whatever we discussed. So these are the, so easily we can understand how it is implemented internally. Okay, so remove method, it is going to call the remove first. If the first node is null, we'll get an exception. The pool, it's trying to remove the element. If the node is null, it is not going to throw any exception. Simply it will try to return null. So whereas element is going to throw an exception, but the peek method, it is not going to throw an exception. So this is what we need to understand. And here if you see, and add first and add last. So what exactly the add first and add last methods are going to do? Because now we discuss about the queue related interface. Now we are trying to discuss about this particular DQ related interface. Okay. Now under the DQ, first we'll go to this particular add first here. Now to understand this particular add first here, I'm trying to comment on these methods here. These are the queue related methods. Now we are discussing about the DQ related. Now add first here. Okay, so add first, except add first and add last, we discuss all the methods. We discuss all the methods. Now add first. So what exactly we need to provide? Now here I'm trying to providing 61 here. Okay, here I'm trying to providing 61. Now what exactly the add first is internally implemented. So now I'm trying to debug. Now add first, we stop the breakpoint here. We are going for this particular add first here. Now if you see link first. Okay, link first. Now what exactly the link first is doing? It will try to add first element here. Now go to the link first here, loading the first. Okay, so loading this particular first node. Now what is the first node? 10 record. Now if you see, this is the first node. So first node we already observed, it's contained the previous node as a null. It's contained the previous node as a null. Now we observe the first node we observe. Okay, later if you see, we are trying to create a new node. How we are trying to creating it? Here we are using the new operator. So new operator, what it will do? It will try to create a new node here. Okay, now what are the value we are providing? Previous value we are providing null. So that will treat as the newly created node as a first node. Okay, and for the first node, next value is contained, but previous value does not contain. So here if you see, the next node we are having the reference as F. What is the F here? Here we load this particular first node here. Here we load this particular first node F here. So same F we are passing here. So it is a constructor parameters. Now if you see this, now it is a previous node is expecting. Okay, so this is something like first one is previous node element we are having, and next. Now this node constructor is having 3 parameters. The node constructor is having 3 parameters. First one is previous, second parameter is element like value, third parameter is next node reference. Now if you see this, we are providing the next node reference, but we are not providing the previous node. So previous node, what we are providing? We are providing as a null. So that what we can observe here, previous node is null, so that we'll treat as this is the first node here. Okay, so we created the new node. Now we are initializing first node as a newly created node. What is a newly created node? Something like a 61. Okay, so now you can see next node we are having previous node. But if you see the next node, internally it is contained the previous also null. Now we need to fill this previous one. We need to fill this value. But how I'm trying to fill this? Here using this particular f.previous. f.previous. Now if you see this is the f here. The 10 value, we observe the s. Okay. Now for this 10 record, we are having previous as a null. But line number 136, what we are doing is f dot previous is equals to new node. F dot previous is equals to new node we are having. So this is what we need to understand here. Now you can see, now if I'm going to see next and previous. So this particular 10 record, now it is not going to treat as a first node. So why it is not going to treat as a first node? Because it's contained the next and the previous. If we want to treat as a first node, the previous node become null. Okay, so which node we are going to treat as a first node? Now this is 61. Okay, previous node is null. Now whatever the value we provided, 61. And which method we are calling? Add first. Now what exactly it is doing? It is trying to add a first node as a, so currently, now if you observe these 4 records, like 4 nodes we are having. Okay, 4 nodes we are having. Now here if you see 10, 20 and 30 and 40. So now I'm calling this add first. So add first, what exactly it is doing? It is going to create a node on top of this, and here the value we are providing 61. But so this previous node we are making as a null, and next node it is contained to this particular 10 here. So it's a simply linked list. Basically just it is going to make the relation one node to another node, like previous node, next node. So these are the relations we are going to make here. Okay, so previous node is this, and next node is this, and the previous node is this, and next node is this. Okay, so this is a way it is going to provide these are the relations here. These are the relations we are going to provide. Now, so we observe the add first, how it is implemented internally. Okay, so any questions? Any questions regarding this particular, the queue related method, whatever we discuss here, as well as DQ related one method called add first here. So any questions?
Yeah, trainer. May I know where is the where it will use in the real time, please? So actually, I am a beginner. I'm very sorry to asking you this question.
No problem. The method itself is saying add first, because if, for example, so using this particular add method, we inserted like a few records. For example, so 5 records we inserted. Now on top of this particular 5, I want to insert one more record as a first record. Then we can go for this particular method.
Okay.
So this is the way only we are going to use. Otherwise, we can go for the add method. The add method internally, it is going to create in the sequence order one by one, based on the how many times we are going to call the add method. For example, if you are calling add method 4 times, first time, first it's going to create a first node. Second add method, second node. Third add method, third node. Like it is going to create it.
Okay. Thank you.
Okay. Now, so another important one, add last here. So we discussed about the add first here. Now we need to observe about the add last here. So this is the add last. Now what exactly this particular add last is doing internally? Okay, so what exactly this add last is doing? Now here I'm going to provide the 65 here. So 65 is the our last value. 65 is our last value. Now what you need to understand basically here, let me run the same example. Okay, so add first we observe. Now we are discussing about the add last here. Now you can see link last. So this link last we already familiar multiple times here. Okay, so now what you need to understand here, what exactly the link last method is going to do internally. What exactly? The link list. Now if you go to this particular link list, now we are loading the last node. We are creating a new node with help of this particular previous node as a last node. Next node we are making null. So what is the observe? First, if we are trying to create a first node, so next we are referring. Okay, the previous we are making as a null. whenever we are trying to create a last node, now the next node we are making as a null, but we are providing previous node. Okay, it's a simple understanding here. For the first node, previous node is null. Okay, for the last node, next node is null. So this is only the understanding here. Getting the point? For first node, so this particular first node does not contain any previous nodes here. Now if you see the same concept here for the last node does not contain any next node here. So the next node will become null here. So this is what we need to understand here. So these are about the important section about the first node and last node. Now we are trying to create a last node. Now this last node we are making as a newly created node. So this is the newly created node 65. Now you can see next node is null, but here we are having a previous node. So what is the previous node? Something like 40. But for the 40 also we are having next node is null. But where we are doing it, we are trying to replacing the null value at line number 151. Okay, so if you see this here, if you go to the previous, next node is null. Now once I execute the line number 151, now I'm coming back to the same previous. Now you can see next node we are having. Earlier this particular next node is null. Okay, earlier this particular next node is null. So these all about the we need to understand here. These all about the we need to understand regarding this particular link last year. So add first method as well as add last method we discussed. Now if you see, so 61 here we created as a first record, 65 we provided as a last record. Now here you can see 61 it is coming as a first record and 65 it is coming as a last record here. This is what we need to understand here. Okay, so is it clear? Add first and add last. Still any questions? Okay, so if you don't have anything, now we'll go to the another method. So add first and add last we observe. But what about this particular offer first and offer last? Now carefully observe, add first it is not going to return anything. These are the void methods. But if you see the DQ offer first, it is trying to return the Boolean value. Now we need to observe the what exactly the Boolean values are going to be returned here. Okay. Now let me call this particular offer first here. Linked list dot offer first. Okay, so offer first. Now here I want to provide as a 32. Now 32 I'm trying to create, like I'm trying to create as a first node. Now if you see this internally, offer first, what exactly it is doing is it's calling the same method called add first. Okay, it is calling the same method called add first. Now add first internally we observe link first. Internally we observe link first. The link first it will node the first node, it will come up with a new node and it is going to provide the previous node and next node references here. So this is what we need to understand here regarding this particular add first and add last. Okay, the add first and offer first both are going to do the same operation. But what is the differences between offer first and add first? Offer first internally explicitly it is trying to return the true. Okay, explicitly it is trying to return the true, but whereas add first it is not going to return anything because it is a void method. Now to understand this, here you can see it is a void method. It is a void method. So this is what we need to understand. But offer first it is a Boolean method. Because of this it is trying to return this Boolean value called true. Same thing here you can see offer last. So add last method we are calling and we are trying to return a true value explicitly. These are about the important section we need to understand regarding this particular offer first and offer last here. So these are the 4 methods we observe. Okay, so we discuss about the remove first. Now whenever you are calling the remove method, internally it is calling the remove first. Now what exactly this particular pull first will do? So now if you see this, so pull first, it is not going to throw an exception. Okay, whenever we don't have an object, so it is not going to throw an exception. Simply it will try to return the null here. Simply, it will try to return the null. So this is only the main differences. Now you can see we are loading the first node. If the first node is null, returning null. Otherwise, we are trying to removing this particular first node. Unlink is nothing but we are trying to remove the first node here. Now this is we discussed in the previous example. So this will call it as a ternary operator. Now if you see this question mark, what exactly it will do? Now if this particular expression, if it is true, okay, so after the question mark, whatever we are going to write, so that is the value it is going to return. Now for example, if it is a false, okay, the before the question mark, the expression if it is a false, now after the colon, whatever we are going to have, it is going to be written. Now if you see this, so this is the expression. What is the expression we are having? This particular code. Okay, f equals to null. If it is returning true, simply will return true. Simply will return null. If it is returning false, simply it will go to this particular method and it will try to unlink the first node here. Unlink the first node. So this is what we need to understand here. This is what we need to understand here. Now same thing it is applicable for the pool last also. Here only same. Last node we are loading. If the last node is null, it will try to return null. Otherwise, it is going to remove from this particular linked list here. So this is what we need to understand here. Now these two methods are going to throw an exception, remove first and remove last, whereas the pool first and pool last, it is not going to throw any exception. Simply, it will try to return null. Now what about this? So get first. Get first basically will throw an exception if the first node is not available. Okay, if it is available, it will try to return the value. Okay, it will try to return this particular value here. So whereas the peek first. Okay, so what exactly this particular peek first will do? It will try to load the object. If the object is null, simply it will return null. Otherwise, what exactly it will do? It will try to load the item value. So carefully observe. Again, I'm trying to explaining this particular method first. Linked list dot get first method. Okay, so now you can see get first. What exactly we are doing? We are loading the first here. If the first node is null, we are throwing an exception. Okay, get first. Same way if you see get last. Now we are loading the last node. If the last node is null, throwing an exception. But what about this particular? This method called peek first. So carefully observe the differences here. Okay, so observe this particular differences here. Now get first method, if the node is null, it will throw an exception. What about this particular peek first here? The peek first, if you see, same method we are loading, like same node, first node only we are loading. But here, if the first node is null, we are not throwing any exception. So simply we are trying to return the null. So this is the main differences between these methods. So add first, add last, offer first, offer last. So remove first, remove last. Okay, so we need to observe which methods are going to be throw an exception and which methods are going to be, it's not going to throw an exception. Simply it will try to return the null value. Okay, so this is all about the important section about the queue related method as well as dequeue related. Now finally, what you need to understand, these are the four methods here. So carefully observe. Remove first occurrence. Now what exactly the remove first occurrence is going to do here? Now I'm trying to comment on this. Linked list dot remove first occurrence. Now what is the value we can provide here? Something like I want to give as a 65. Okay, I'm giving as a 65. Now we need to understand how exactly this remove first occurrence method is going to be implemented. Now if you see this remove first occurrence, now we are calling the remove method. Now what exactly it will do? It is calling from the beginning onwards. Okay, first is nothing but first node we are loading. It will keep on repeating until this particular condition will satisfy. Okay, until the equal condition will satisfy. Whenever condition will satisfy, we are calling the method called unlink. Okay, unlink method. Now what exactly the unlink method will do? It will try to remove the conditional, whatever the condition is satisfied node here. Okay, so these are about the important section we need to understand here. These are the important section we need to understand here. Now, so what is another method we are having? So same thing, last occurrence. Now what exactly the last occurrence will do? So it will also do the same operations here. It will try to find out the last node and it will try to remove the last node of this value here. Okay, now, so remaining two method, push method as well as pop method. Now let's observe how this particular push method is implemented. Linked list dot push method. Here I'm calling 67. Okay, here I'm calling this particular 67 value. Now what exactly the push method is doing? Now observe carefully. Push method, it is calling a add first. Okay, push method internally it is calling the add first. Add first we observe, link first it's calling. Now we are loading the first node, creating a new node with help of this particular E, whatever the value we provided, currently 67. Okay, so 67 value we are going to provide here. Now whenever we are providing this particular 67, okay, whenever we are providing this particular 67, now what happens internally? We are going to have this particular node references, we are making the remaining changes here. So this is we already identified here how exactly this section of codes are going to be implemented here. Okay, these are about the important section about the push method. Now what about this particular pop method? Now if you see this pop method, remove first. Okay, push method will add a first node, the pop method will remove the first node. Okay, so these are about the important section about all the queue related method we discuss here as well as dequeue related methods also we discuss here. Okay, so still any questions regarding this particular linked list as well as array list here? Okay, now if you don't have anything, okay, so now what you need to understand basically here, so these are the method we discuss about the under the linked list. So tomorrow we'll discuss about the important concept to call so set related method. So like set related implementation classes. Now currently we discuss about the list related implementation classes. Okay, so these are the important sections. So now try to practice the one by method, how exactly it is implemented internally. Now if you observe the internal implementation, you can easily understand how this entire collection framework is implemented internally. Okay, so this is all about the important section about the linked list class. So tomorrow we'll continue the set related important concept to call what are the implementation classes we are having for this particular set interface and how exactly each and every class internally it is implemented. So we'll continue tomorrow the another implementation class.